Hello everyone, my name is B. Satvik. I am from CSCD section. My roll number is 20951A05G3. Today my topic for DAT concept video is binary search. Introduction. The binary search can be implemented only on sorted list of elements. The process starts with finding the element at the middle of the list and comparing the key value with the element in the middle of the list. If the value of the key is less than the element in the middle, then search process the key to the list up to the middle of element. And if the value of key is greater than the element at the middle, then search the key from middle element to the end of the list. Binary search is also known as half interval search or logarithmic search. Is the search algorithm that finds the position of target value in a sorted array. Binary search runs at worst logarithmic time, making big O of log n comparisons where n is number of elements in array and log is the binary logarithm, and using only constant big O of one space. Algorithm. Binary search of a of 0, 1, 2, 3, so on up till n minus 1 comma key. Low tends to 0, high tends to n minus 1. While low is less than or equal to high, do m tends to low plus high by 2. If key is equal to a of n, then return m. Else if key less than a of n, then high tends to m minus 1, else low tends to m plus 1. Example, let the numbers given be 4, 6, 7, 9 and 10 and the key is 9. So according to the algorithm, these numbers are to be sorted in a 1 dimensional array named a of 0, 1, 2, so on till n minus 1, where n is equal to number of elements, i.e. in this example 5. Thus, according to the algorithm, a of 0, 1, 2, 3, 4 is generated and key value is passed in the array, that is 9. Binary search of a of 0, 1, 2, 3, 4, comma 9, low equal to 0, high equal to 4, while 0 less than or equal to 4, iteration 1 is equal to m equal to 2, low equal to 3. Here key is equal to 9, greater than a of m, that is equal to 7. Thus it executes last else condition. Since 3 less than 4, loop will continue. Iteration 2, m is equal to 3, return 3. Since key is equal to 9 is equal to a of m is equal to 9, where m is equal to 3, it returns 3 and thus ends in binary search here by returning the index where the key value is stored. Time analysis. Suppose we have an array A and in this array we are searching for a value k. If A has no special priorities, then there is no better way to search k than linear search, to start at the beginning and go through the array one step at a time, comparing each element to k in turn. This the time it takes on average, and in the worst case is linear, comma or big O of n to the number of items of the array. But if A is a sorted array, there is much faster way, binary search, to look for k. In binary search, after each iteration, the length of the array we are looking in gets cut in half. Binary search can be analyzed with the best, worst, average case number of comparisons. These analyses are dependent upon the length of array, so let n is equal to modulus A denote the length of array A. The number of comparisons for the recursive and iterative versions of binary search are the same. If comparison counting is relaxed slightly, for recursive binary search, count each pass through the if then else block as one comparison. For iterative binary search, count each pass through the while block as one comparison. Time analysis. Best case big O of 1 comparisons. In the best case, the item X is the middle in the array A. A constant number comparisons, actually just one, are required. Worst case big O of log n comparisons. In the worst case, the item X does not exist in the array A at all. Through each recursion or iteration of binary search, the size of the admissible range is halved. This halving can be done sealing log n times, thus sealing log n comparisons are required. Average case big O of log n comparisons. To find the average case, take the sum over all elements of the product of number of comparisons required to find each element and the probability of searching for that element. To simplify the analysis, assume that no item which is not in A will be searched for, and that the probabilities of searching for each element are uniform. Advantage and disadvantage. Advantage. Binary search is optimal searching algorithm using which we can search desired element very efficiently. Disadvantage. The algorithm requires the list to be sorted, then only this method is applicable. Application. The binary search is an efficient searching method and is used to desired record from the database. For solving nonlinear equations with one unknown, this method is used. So this is all about the binary search and its time complexity and algorithms, and this comes to the end of the concept video. Thank you.